All right, so in this video, we are going to look at these things called forces and how they result in motion. And by the end of this video, you should be able to explain the effects of balanced and unbalanced forces that are going to be acting upon an object. So let's get started. So before we can dive into unbalanced and balanced and friction and all of that, we need to understand what is force. And force, by basic definition, is a push or a pull. So you see down here we've got this thing called net force. Net force is just the combination of all that pushing and pulling that happens. So how do we measure force? Well, force, just like we measure distance in inches or meters or kilometers, we measure force in an SI unit called newtons. Now, this sounds pretty familiar. Can you guess who this was named after? If you said Sir Isaac Newton, you were right. So the Newton describes force, and when we write it, we use the symbol capital N. Now, this is very important in science and math that you use your units, okay? So that when somebody's doing an experiment or somebody's trying to read your work, they understand fully what you're writing about. So, there's two different situations that we could be in here. We could be in balanced forces, or an object can have unbalanced forces. So, if it's balanced, well, think about that, right? If something's balanced, it's equal, right? So, in balanced forces, the net force, so all those forces pushing in and on an object, they're all going to cancel each other out. It's going to equal 0. And it is going to result in no motion. Very, very important. Balanced forces mean no motion is going to occur. However, if you are unbalanced, right, normally something's a little heavier than the other. So in an unbalanced force, if an object has unbalanced forces acting on it, one force is going to be stronger, one or more. It could be multiple forces that are stronger than another. Unbalanced forces always result in motion. So let's look at a kind of diagram of this, and I would like you to draw this diagram in your notes. It will help you kind of understand this idea of net force and movement. So we are using newtons here. We have got a block, and on one side, somebody's pushing with 60 newtons, and on the other side, somebody's pushing with 60 newtons. First of all, let's figure out our net force. 60 newtons over here cancels out 60 newtons over here, resulting in 0 newtons. Is this object moving? No, it's not, right? Because you have 60 here, 60 newtons here. Neither one's going to win. It's going to stay put. On the other hand, we have got unbalanced forces. And in this example, we have somebody pushing with 20 newtons and then somebody pushing with 60 newtons. Who's going to win? This guy, right? So we cancel here out. We cancel 20 with 20, leaving us a net force of 40 newtons, right? And 40 newtons to the left. Why is that important? Why is that left part important? Well, it tells us that this object is going to move where? To the left. Absolutely. This person's stronger. They're going to be able to push through this force and keep going. So objects in daily life and just all around us are always going to encounter a couple forces. And one of these forces is called friction. Friction is a force that's going to hold back the movement of an object. So if you've ever tried to push a box that's real heavy, or if you tried to swim through mud, you're encountering this thing called friction. There's 4 different types that we're going to look at. But before we do, just kind of an idea of what friction might be. If you're rolling a soccer ball down the field, right? You're playing soccer, you kind of roll it down the field, and nobody else touches it. Eventually, what is going to happen to that soccer ball? It's going to slow down, right? And then eventually, if you wait long enough and it doesn't roll off a cliff or any of that, then it's going to stop. And that is all due to this little force called friction. We're going to talk about 4 different types. First up, we've got static friction. So static friction occurs between stationary objects. Okay, stationary objects are going to be not moving, right? That's why they're stationary. And so it's going to occur between that stationary object and the surface where that object rests. So for example, we've got the blue man here trying to push this, what looks like a very heavy bookshelf. So you are going to find static friction between this blue man's shoe and the carpet. Okay, his feet aren't moving, so that friction is keeping those feet from sliding. You also have static friction between the carpet and the bookshelf. Okay, as he tries to push that bookshelf, it's going to be hard because he's going to have to overcome the static friction that is right through here. Neither one of these objects is currently moving. The man is not moving, nor the bookshelf. That is why it's called static friction. So if you need to make a little note, you need to make a note that it's going to say static friction is going to always involve objects that are currently not moving. So next up, we have this thing called sliding friction. So just like its name suggests, a sliding object is slowed down by the surface it's sliding over, okay? So as something slides across another object, it's going to produce friction. It's going to try to keep it from continuing to slide. Let's think of an example. A box sliding on the floor. Okay, the motion, it's trying to go this way, but the friction wants to keep it from that, and it's kind of pushing it that way. So the person pushing this box is going to have to push harder to overcome that friction. So let's think. Is it easier to push a box across carpet, real shaggy carpet, or tile? Most likely the tile, right? It's a smoother surface, producing less friction than the carpet. It's easier to overcome that sliding friction. Next up, just like in our example, we've got rolling friction. Again, just like its name suggests, rolling friction is that resistance that's created by an object rolling across a surface. An example would be a soccer ball rolling on the grass, right? Eventually that ball is going to slow down or stop due to that friction. Fourth, we have got fluid friction. So when you think of fluid, what do you think of? Most people think of just like a liquid, right? Well, fluid is more than that. Fluid is liquid or a gas. So just because you're not rubbing up against a surface like grass or carpet or the floor, you're still encountering friction. It's that resistance of an object's motion through a liquid or gas. So a couple of these examples, if you watched the Olympics this summer, you saw Katie Ledecky swim way faster than her opponents, and she was encountering, as all the swimmers were, fluid friction. So the water was producing a resistance against her trying to move quickly through the water. We also see this in airplanes. So as they fly, they encounter resistance from the air. So their power has to be strong enough to get through that resistance. So thinking about friction, friction is going to be that resistance as an object against an object that wants to resist it from moving. Okay? So as always, keep calm and rock on, Hillburn Hawks.